first thing I'm going to note is that this is a work that's primarily undertaken by Filip Krikava. He's he's a very nice person that I love working with, but he's unable to be here today because he's waiting for a new arrival in his family. So pretend that I'm Filip. I'm Filip, okay? Everybody, look at me, I'm Filip. This is his work that I'm presenting. So implicits in Scala are, I don't know, some people have probably heard of them. They're a weird language feature that not a lot of other languages have. The notion of implicit parameters came from Haskell in 2000, and there are some other sort of implicit, like, things in languages like Coq and whatnot. But in Scala, they've kind of found their way into developer life sort of workflow. So a lot of software engineers in Scala make heavy use of these things all over the place. And just to give you a quick example, to give you like a sense of what these things look like, maybe you have a piece of code that looks like this, where you have a string, and then you say, okay, I'm going to call this en español method on the string. Clearly, that shouldn't compile because string doesn't have a method called en español. Normally, people don't put that method on implementations of string. But in Scala, this might actually compile because the way that this little example might work is that perhaps the Scala compiler is able to find some kind of method that converts a string to something else that has the required method, which could resolve the type error that might pop up here. And then this conversion will be inserted silently, and the code will be rewritten. So that at runtime you might actually get something that you might expect, like this, to be returned. So this is a quick sort of taste of like what these things might look like. And if you go back to Martin Odersky, the sort of creator of Scala, he at one point even claimed, hey, if there's one feature that makes Scala Scala, I would say that it is definitely implicits. So just to say a few more words about these things, it's not just this notion of like an implicit conversion or like an implicit function, but it's a few things. So we have a notion of implicit parameters, so that you don't have to explicitly pass parameters that might exist in scope that the compiler can write into your code for you. And then there are some other things called implicit classes, implicit objects. These are usually used to implement a number of things like extension methods, type classes, things like that. You can even do some lightweight, like sort of proofs kind of in the type system, extremely lightweight. And really the goal of these things is to reduce boilerplate by leveraging what the compiler already knows about your code. Get the compiler to rewrite things for you. And these things, used in these patterns make it really easy to embed DSLs in Scala, and so you can implement all kinds of things that look like language extensions, things that look like they would be implemented in a compiler but outside of the compiler in libraries. And so you might ask, all right, so we did this large-scale empirical study where we crawled around and got a bunch of examples of what people do with implicits. You might say, well, why do this? This isn't the sort of thing that you usually see at a programming languages conference, and we did this because we think it's important to make a catalog or to kind of have a retrospective for language designers and software engineers on sort of how this language feature was actually used in the wild. So it was meant as sort of a retrospective on introducing this thing into the wild and having real software developers pick it up and use it, and then watching them misuse them as well. So this is more of just a bunch of takeaways that you could say, are for potential language designers of future languages, or things that might be good and bad that people might do with these things, at least as they were presented in Scala. And of course, I'm going to go on a small rant at the moment. I think as programming language designers, we should actually care a lot more about how people use the designs that we present to them. And I see a lot of sort of research going along this line, right? So you're a programming language designer and you come up with some sort of new language or new technique, and it's it's got some great property. It's more correct than something before. It's more general. I don't know. There's something great about it. And then we just give this to people and hope that it solves all of their problems. And I ask, well, why don't we do more of this, where we ask ourselves, does the language or the technique or the thing that we gave to people, does it actually help them? What do they do with it? Does it make their lives worse? So that's why we did this project. We wanted to try and answer what did implicits do. So just to give you a quick sort of sense of how everywhere they are. So this is about 15% of the Scala code bases on GitHub. This little graph here represents 7,280 projects, about 18 million lines of code, 29 million call sites, and in all of this there are about 370,000 implicit declarations. And what you see here are the number of implicit declarations on this axis, and these are the projects. And you can see that about 78% of these projects define implicits. And there are 8 million call sites. So, and actually 98% of all projects that we found make use of implicits somehow. So they use them, in a library or something. And actually 27% of all the call sites and all the Scala code bases made use of implicit somehow, which is nuts. You wouldn't expect this being the case. I mean, this is not what anybody guessed what would happen. Basically, almost a third of all call sites involve implicits. And so, all right, just to show you, what these things might look like, you see this little expression here. How many call sites do you think there are in this? Naive guess is 3. The real answer is 11, obviously. So we'll, break this up. So just on the one side of this tuple here, you have all of these things that it gets expanded to. So this ordering to ordered is a lens between this thing called ordering and ordered, obviously, between a sorting strategy and a single natural ordering. And the ordering one is a trait that represents a strategy for sorting instances of T, and ordered is a trait that represents the single natural ordering of T. Okay. So one of these is an implicit conversion, and this ordered stuff, these are parameters, and that's just one side of this. So that's just like, hey, to show you how many appear that you might not expect. So okay, how are these things used in the wild then? I mean, that's what the title of this talk is, right? What we did in this study, we collected a bunch of real-world Scala projects. I gave you a quick glimpse on the earlier slide, and we split them into a bunch of different categories. So we broke things into libraries, things that are published and indexed as libraries. Small applications, less than 1,000 lines of code. Large applications, over 1,000 lines of code, and then test code. So code from both libraries and applications. And what we wanted to do was find out how implicits are used. So do projects use them? Do they define them? Where are they coming from? Are they always coming out of the Scala standard library? Is everybody only just reusing the ones that we provide for them in the Scala standard library? Or are people actually defining them themselves? And then on top of that, people have invented a whole bunch of different patterns to use with implicits, things like type classes. And what are people doing? Can we search around in these code bases and identify how often and where and when people are using different patterns? And then, of course, is there a compilation overhead? And of course, this would seem like it should be done in a few weeks, but it took quite a much longer time than that, and I'll show you why. So if you want to break down this example from the previous slide, what you have are a number of so you have this ordering to ordered implicit conversion, and then you have these implicit defs on this tuple 2, and then you have this implicit int object, and all of this is kind of how you construct this example. And what's important to note, doesn't matter to get into a lot of detail. The important to note is that you can't just look around syntactically in the code, just grep around. These use sites are not present in the syntax, right? You can't see that here. It just expanded into all of this other stuff. We need semantic data, so we need to compile that in order to get the semantic data. And another thing is that these things are resolved statically at compile time. There's no dynamic dispatch, which is also nice because all we have to do is compile. So we don't have to worry about dynamic dispatch. We can just worry about compilation, right? But the thing is that we need to compile all of these code bases, and we need to get the static information from this compilation step, right, in order to do this analysis. And to do that, we used a thing called Scala Meta. It's a library for tools, or for tooling authors. The idea is, to make it so that it's easy to query and also sort of analyze Scala programs for tools. And it stores the information in this thing called a semantic database, which makes it easier to query, what it has, these sort of ASTs that it's built up. So it has this data model of the semantic information that's extracted from both Scala and Java. It's suitably run as a compiler plugin, and it contains, importantly, what's for us, it contains synthetics. So trees added by basically added by the compiler that don't appear in the original source code. And this is what the analysis pipeline looks like. We'll break it down into pieces. So the first part basically grabs all the projects from GitHub, extracts the project metadata, and we do this from GHTorrent, and we figure out what's libraries from Scala Deck, which is the Scala package index. And then we grab a bunch of data from GitHub. So we figure out how many committers, how many commits, how many stars, things like that, and the build system. We get the build system out of this too. Of course, we can't necessarily support every build system that exists on the planet. Then, of course, we count the lines of code. Then from that step, we filter out projects that we can't, that are just unsupported in sort of the tool chain that we have. So SBT is the Scala build tool. So we filter out projects that do not use Scala SBT. Almost all projects do, so that's okay. But there are a number of projects that aren't necessarily compatible with this Scala Meta tool that we had mentioned. And basically, that has to do with like a version of Scala. We also get rid of duplicate projects and uninteresting projects, cute little like sandboxes like Hello World in Scala. We filter those out. Things that have less than 2 commits or have less than 2 months activity. Yeah, so I mean, the reason why it's important, for example, to filter out duplicates is that 37% of the code base and 102 repositories contained copies of Apache Spark, which has hundreds of thousands of lines of code. So it's important to get rid of all of these duplicates for that reason. And in the end, after this step, we threw away over half of the projects, yet we kept 97% of the GitHub stars that we had sort of grabbed. Then, of course, we do the compilation step because we need this, to figure out the synthetics from all of these from the semantic DB business. So in this case, we found that 4,000 out of 11,000 projects failed to build. So we ended up losing some more projects here. And these are due to a number of reasons. Some didn't have dependencies found. Something was there was something published on Maven or Bintray that was removed. A bunch of compilation errors or broken builds. So we threw all those away. And then we began doing this extracting implicits and then analyzing them phase. And it's important to note that this is the part that's specific to implicits. The rest of this is actually just reusable for anything that you want to sort of statically analyze about Scala. And here's a quick glimpse of the extraction step. So semantic DB will give us sort of an AST representation that looks like this. And what we do is we basically rewrite it so that it's easier for us to query. And it's easier for us to go back and forth between declarations and uses. And that's what we do in our model here. And this is what the final corpus looks like. So this is 15% of all publicly available Scala code on GitHub as of the beginning of 2019. And so we have these different categories here. Small applications are in red. Large applications are in blue. And things that we have managed to identify are libraries are yellow. So things that are libraries are are things that are published on Bintray or Sodatype and that are indexed as a library. The rest of these things are just code found on GitHub. And what we can see here is that basically, this is the number of commits, and this is the source line excluding the tests. So the larger projects are up here, and the larger and the busier projects are up here. So as you can see, libraries start to go up into this corner, and smaller personal projects kind of fall into this corner, just to give you a sense of the data that we're working on. And this is what we have collected data on that we've produced observations about. So we wanted to understand the overall usage of these things. So where are they, what's using them more, etc. We wanted to understand how people use these patterns, things like type classes. We wanted to understand how expensive it was, in terms of compilation overhead and also the complexity. So this is separated. So if we take all of those code bases and we look at the call sites involving implicits, like I said, 27% of all call sites and all of the code bases involve implicits. We can see that a lot of our testing libraries in Scala make use of implicits, so you see a lot more implicit usage there, and you see actually not too big of a difference between large apps, small apps, and libraries, which sort of suggests that everybody is using these things, and it's not necessarily something that only happens in libraries. And you want to, so you ask, okay, so this is usage, right? This is who is using them. This is who's defining them. So they end up being defined a lot in tests. And again, so we have external dependencies, the local project that we were analyzing, and then the Scala standard library. So we can see a lot of implicits are being sort of declared in the Scala standard library. Fewer are being declared in the local projects, and a lot more are being reused from external dependencies, sort of the main point here. And here's a fun point on implicit conversion. So that was the one that I kind of illustrated earlier, where you might want to convert to another data type. It's like an implicit function. There are, if you look at the numbers here, so this is the same. So basically, the number of implicit conversions across all of these same categories. Slinky, this project here, has 34,000, whereas the rest have 446. You might ask, well, how in the heck is that possible? It turns out that these are all generated. So this is a React library or something for Java, Scala JS, and these are all synthetically generated, which is incredible, if you ask me. So the paper covers a number of patterns that I do not have time to get into today. I'm going to talk about type classes. I'm going to quickly mention AntiPatterns that we've found, and then the rest of this is in the paper if you're interested. So the type class pattern in Scala, we found 11,000 instances of this, so 30% of the implicit calls. And of them, most of them were in the Scala standard library. So in these places, usually in the Scala collections, predef is a thing that is basically, a number of sort of things that you just get when you open Scala and you start using it in a REPL or something. And then the other 15% is in libraries, or 15% is in libraries, and the rest comes from functional programming frameworks, which is kind of interesting because what we found was that about 40% of all projects make use of these functional programming frameworks, which I found to be particularly surprising because I thought they were a little bit more niche than that. Apparently they are. Some anti-patterns. So there are two anti-patterns worth mentioning. The first one is unrelated conversions. Public top-level definitions defined outside of either of the from or the to compilation units. A good example of this is actually something like array to int being introduced into like some random place in a project. That's clearly not great. And then the other one is conversions that go both ways. So this is problematic because these conversions are not necessarily visible. So it's difficult to reason about the types at the given call site because some unexpected conversion could happen. So this was something that was sort of an issue with the Scala and Java. There was a library once that's now deprecated that would convert between Scala and Java collection types. So this is a sense of the how often these two patterns appear. So it turns out that they appear actually. I wouldn't say in a majority of code bases or anything, but 16% we found these top-level conversions that could be problematic, and then we found about 10% of projects making use of this once deprecated Java Scala collection conversions, and then another 26% of libraries doing this by themselves unrelated to that library, which is concerning, I guess. And then I'm going to mention one more thing before I wrap up, and that is sort of the mention of overhead. So this is just a quick example of a serialization library that uses implicits to generate the serializers, the encoders. And it's not really important to pay attention to how everything works, but we just have something, this course here, and all we want to do is sort of convert it to JSON. And this is what gets generated. Oh no, I can't. There we go. It's about 200 lines of code that gets generated by this framework that makes use of implicits, and the implicits generate that code for you. And it does type class generation using macros, so it makes use of macros and implicits to generate code. And it uses this library called Shapeless. And it's important to note that people noticed this became expensive, and I'll show you a graph of how expensive it became. That this became sort of a best practice to try and cache these serializers so that you wouldn't have to, every time you use them, generate these 200 lines of code. And so this is the last graph I'm going to show you before I wrap up. And so basically, the point to observe here is that this is compilation speed on this axis, and this is the number of implicit call sites per lines of code. And the red line and the red dots represent libraries or application code that make use of this type class generation that I showed you on the previous slide, where it ends up generating a whole bunch of code using implicits. And as you can see, the compilation speed is notably slower for these libraries. For small ones, it's around 200 lines per second, all the way down to less than 100 lines per second, whereas without them, you're closer to 400 lines per second. And with that, I'm going to sort of give you a few takeaways. So the first point to note is that implicits basically are everywhere. They percolated to basically every nook and cranny in the Scala ecosystem. There's hardly any API without them, as they enable elegant architectural design. A lot of people believe that. I believe that too. They allow one to remove a lot of boilerplate by leveraging the compiler's knowledge about the code, but they can also easily be misused if taken too far and hurt the readability of code. So the sort of takeaways here are, if you're a library designer or a language designer or a library designer, things that you have to worry about if you're worried, if you consider using implicits in your language. Coherence is a problem that has affected a number of languages. So you might want to consider, the complexity involving that. Compile time and performance is important for both library designers and language designers. Tool support is really important. Expressivity, I think that implicits in Scala are a bit too expressive. That's why in Scala 3 they are being greatly limited. And for library designers, the main point to take away is it's really easy to over-engineer these libraries using implicits. And of course, you shouldn't use any of these sort of problematic patterns, unrelated implicits that go both ways, or even conversions that might change semantics. So these are the general takeaways, and with that, I'm happy to answer questions if there's time.
Yes, I think we can do one or two questions.
It's really hot in this room, for the record.
Hi, thanks. I'm wondering if you could sort of try to connect the implications of implicits with sort of the trade-offs of use. I mean, you gave some, I'm not sure if these are exactly opinions or sort of where these recommendations came from. But I wonder,
yeah, so these, do you mean the problematic patterns, the ones that I mentioned, or?
Yeah, that's one example. I guess I'm wondering overall, if I'm designing a new language, should I add implicits? Will it help my users?
So I mean,
because it's a
of course, so there's a lot more detail in the paper with some observations and sort of arguments that are a little bit more intricate than the ones I'm providing to you right now. But if you want to talk about some of the problems, a lot of these have been, we have citations in the paper sort of pointing to talks and mailing list threads and things like that, where people have sort of, as a community, identified like, this is bad, this is good. And the things that we're sort of identifying as problematic are things that we've just gotten from the community. We're not just claiming this ourselves. And we talk about other things in the paper. I mean, mostly it's related to compile time performance, and sort of some of the problems with expressivity and like naming and things like that. And this stuff is discussed in more detail in the paper. So basically the argument would be some of the points that you are interested in, I would check the paper for. And a few others, I can give you pointers to the problems with coherence. And I can show you some other pointers if you're interested in at least Martin and his reflections on some of this stuff and the redesign in Scala 3. But I can't quickly summarize it right now. That's the problem.
Thank you.
Yep.
All right, let's thank Heather again.
Thank you.